Welcome, Vaibhav, for the issue, this interactive session. One of the things we often talk about is, we have a lot of interaction with academia,
Right.
okay, through various initiatives that we run. And there is an understanding in the academic realm, okay, that steam is only used in power plants. So typical curricula would involve areas like Rankine cycle and so on.
Yes.
But a much wider role steam plays in process heating. Yeah.
Yes.
So I have interacted with students and faculty saying that steam is actually an old technology. It is something that is no longer relevant in the 21st century, for example. So would you agree to that statement? Do you think it represents the ground reality?
Yeah. First of all, many thanks for getting me onto a platform where I can interact with the academia because most often we as industry professionals, we are busy at our own desk adding value to our customers and trying to share our experience with them. But it's important that we have a good foundation to the whole understanding of steam. And to that extent, the question is very relevant. So I will put it up in two pieces. One is talking about the relevance of steam, and you made a mention about, the whole academic exposure to steam is limited to power plants, and how do you really migrate from that understanding, because that's the first touch point. And second, the relevance to the 21st century. I think that's two parts which would make my understanding to the whole question easier, and I'll try to put forward my thoughts. So the first thing which comes to my mind is, when you look at the whole curriculum and you look at how STEAM has been evolved, we basically look at engineering thermodynamics. That's the foundation of STEAM. And then we look at the applied part of the thermodynamics, which is related largely to power plant engineering. Many institutes would have it as an elective subject. So it's not the first choice necessarily which somebody may opt for as a good engineer. So what I would say is that, if you look at the whole journey of steam, we know that steam started with the steam locomotives, for example. And that puts us into a certain awkward situations to say that, I know the relevance of steam only in a particular gamut of understanding. That's where the whole knowledge and technology is resting, and beyond which there may be a world which I'm not taught, I'm not exposed to, and neither have I ever tried to venture into as the first choice. And then, if you look at now what we would have to react to it is that you have this whole green energy, which is the in thing today. So again, people would say that, are thermal power plants relevant today in the world? Are we getting into more of nuclear power, wind power, solar power to generate green electricity? That's the in thing today. So everybody wants to use green fuels and green electricity. So how do you relate steam as a concept to the relevance of the energy footprint in any of the process industries or the overall big consumers of, the guzzlers of steam and electrical consumptions like the oil and petrochemical markets? You have big chemical plants which would be big guzzlers of energy. And would they be more relevant to use green electricity as opposed to steam? If that's the point which we are talking about, we have to be making it relevant to the production processes. Finally, steam is a utility. It actually engages as a slave to drive the master, which is production. And I would say that, there are two facets which are very crucial when we look at steam as in conjunction with productions. One is to look at productivity, and second is to look at product quality. And there you would find that a simple reason why steam will strike a chord with any engineer is because it has the cleanliness which you expect. It's very clean. It's very flexible. You can put users onto the circuit. You can get them off the circuit. And the biggest point is whenever you read a very huge potential surge of energy requirement, the steam system gives you the flexibility to really look at a big surge of energy because it gives away its latent heat to the process.
Yeah.
It's something which is inherent in the vapor, which is what we call as steam. And that's something which makes it a very meaningful utility media for most heating applications. And let's look at a practical dimension. You have a small laundry which uses steam. to a very complex plant, which I was saying, like oil and petrochemical complex, they use steam. So steam is very vital. And, most of us would have the first cup of tea or coffee in the morning. You're playing with steam. There's no choice. You are in whichever century you are in. You have no choice. You're not going to really prefer a cold cup of coffee in the morning, right? You want to be fresh. So that's where steam plays its role. Now, coming to the second point, which you're saying is, while this whole journey of the 21st century is looking at itself, and we are saying that, so now the steam locomotives, steam-powered boats, the ships, they are all outdated. We're now looking at, greener fuels to really charge up energy. I would again say that if you look at what is happening practically, is that you are looking at the fuel shift which is used for the steam generator. So you're trying to go away from fossil fuels to greener fuels, which are biomass fuels. You are trying to look at renewable energies resources. But finally, what you are trying to do is you are looking at the carbon footprint created because of fuel.
Right.
You are still trying to generate steam using this alternate resources of energy input. But steam plays its crucial role in heating, drying applications. And the simplest example is if you go to any hospital, you would have a sterilizer which has experimented itself with looking at even chemical sterilization.
Right.
There was a hospital right where we are looking at this session in the city of Pune in India. We had a hospital try to look at chemical sterilization.
Right.
And they had a serious problem because, the residuals which remained in the sterilizer was risking the patients.
Right.
Would you imagine that a disruptive thought process could lead to a serious hazard of safety?
Yeah.
That's where they quickly had to retract.
Yeah.
They went back to steam as the sterilization media. That shows the power of, what we are trying to really look at when we look at steam as an energy footprint. In a simple example, which I just tried to put, that it's relevant for us to really feel safe, right? When you enter a hospital.
Absolutely.